Welcome, Bradley Tech and Trade Chemistry Block B1. Thank you again for good attendance. You guys won the attendance award. Did you enjoy your popsicles yesterday? Yes, we bribe you with food for good attendance. Also, I wanted to say thank you for doing your survey. This class had 100% of its students doing yesterday's survey. Those surveys come from the state. I won't see the results. They are wellness. The state wants data on high school students. Thank you for doing that. Also, thank you for singing the proton, neutron, electron song yesterday. You guys did a great job. Great job singing the proton, electron song. We start 2 weeks now that are chemistry of climate change. Who can tell me what climate is? Frank, yes. Average weather over a year for a place. You don't say, Mom, what's the climate going to be tomorrow? You don't say, what's the weather in an area if I want to move there? You say climate for average weather for a day. Our topic focuses on the relationship between the Earth's climate and energy. Who can tell me some of the parts of energy? I know it's physics, but I've mentioned it many times before. Gamma radiation, yes, that has the smallest frequency, most energy, most dangerous. X-rays, radio waves, TV waves, microwaves, visible light going from Roy G. Biv, infrared, ultraviolet. What did I miss? Radio waves are the longest. Yes, all of those are energy. They flow through the air. They don't need matter. Energy coming from the sun includes many of those, not all of them. We're always concerned with infrared heat and light in the visible spectrum, but those other forms of energy, those other frequencies also come to Earth. We will analyze geoscience data to make the claim that one change to Earth's surface can create feedback that causes changes to the other systems. All of the systems we've been talking about for a few weeks now. We have the atmosphere. What's the atmosphere? Frank, yes, all of the air. Geosphere, all of the land and rocks. What is the hydrosphere? Water, not just of the oceans, all of the lakes, all of the ponds, the small pond in the backyard of the farmer, and even the clouds, humidity in the air is part of the hydrosphere. Biosphere, Susie, yes, that is life. Good. We will have a model on day 2. We will describe how variations in the flow of energy into and out of Earth's system result in changes of climate. Much of that teaching will be shining the flashlights on the balls. You can see I have the globes here. You might have done this in grade school. We'll do more detail. We're going to shine the lights on the globes, and we're going to shine them at different angles. And then what we've done, we did this last year, we're going to use magic markers and circle how large the light is on a piece of graph paper at different angles. So we'll collect data, evidence, data. We'll also analyze geoscience data that results from global climate models to make an evidence-based forecast of the current rate of global or regional climate change. That will actually be next week. I may need a little help getting that technology going. Technology and me don't always work. We will use models to predict what will happen in different parts of the Earth in different time frames. Our essential question for today, for today's lab, how is Earth's climate change related to energy? Angle, angle, angle. Everyone say angle. Yes. Everything about different seasons and why you have colder weather in Alaska, warmer weather in Florida. We in Wisconsin are right in the middle, Alaska, Wisconsin, Florida. It's because of the angle of the sun. Our learning intention, we are learning to evaluate implications of the energy to Earth's climate change and success criteria. You students will be successful when you can compare and contrast the relationship between greenhouse gases. Who can tell me greenhouse gas? Yes, CO2, of course. What else? Water, yes, water, very important. Water actually holds more energy in, and methane is the third one we've been talking about. Global temperatures and the predicted impacts to Earth systems. Please take a minute and move to your groups. You will find on your table lab reports with materials and equipment. Ready, go! They're moving to different groups now. As always, when you do group work, make sure there isn't one person who does all of the work and the other three are freeloaders, just getting a free ride on the one person. Also, it's up to your group, but you can and should have somebody who is a recorder, somebody who is a materials getter, two people that are actually doing the experiment, etc., etc. I will leave that up to you. If you guys need help, group 1, 2, 3, 4, 5, if anyone needs help assigning what jobs, I'll be happy to do it. We'll do it randomly. I'll have you do paper, rock, scissors for the recorder. Materials and equipment, chart paper, markers, etc., etc. Everybody get the equipment out. We are going to start. Please watch this video. It's a video that comes from STEM Scopes, our book for this. It shows you how we will do this lab today. Give your attention to the video. I will get the lights. Please watch. Are there any questions on the video? I want you to give me thumbs up, thumbs sideways, or thumbs down for your understanding, your group's understanding of what we'll be doing over the next hour. Ready? Give me a thumb. They're all up. Fantastic. They are all up. I'm going to demonstrate how we do the first part of this. The first part of this doesn't use the globes. It uses the yardsticks. So please take a couple minutes. I'll give you 5 minutes. Tape the yardsticks to your table. We're not doing this on the floor. We're doing this on the table. I don't know why they said do it on the floor. And measure the end of the stick that comes off the table. Put the flashlights in positions. Tape the flashlights in positions. And then get the graph paper ready. Also your protractors. Everyone here should know how to use the protractors. If we need 23 degrees, we will do this as the plane of the earth. The table is the earth. Do 23 degrees up. So set your protractor where the baseline is this. This would be 0. 23 degrees up. That's what everyone should do. And that's, it doesn't say it, but I think we did this last year. I think it's better if you tape your protractor to the side of the table. Tape it like this, so you can see that. Again, it doesn't say tape it, but I think my variation is tape the protractor. And then again, practice, you'll be holding the graph paper. Oh, I forgot. Tape the graph paper onto the backing board. If we're using graph paper by itself at different angles, it's going to be floppy in the wind. If you use the graph paper, plus it'll be impossible to use the marker. Again, it's not too tricky. The first time you read this, you may